Hi Turja.
Hi sir.
Yeah. Can you please tell me about yourself?
Yeah. Thank you for giving me opportunity to tell me about myself. I am Turja. I am serving Larsen and Turbo Technology Services as a physical design engineer since 1 year. So as a physical design engineer, I know from synthesis to GDS2, and during my project I have uses ICC2 and design compiler.
Okay.
As a tool, CDA tools.
Okay. How many projects you have done still so far?
Actually, sir, I was in Odyssey project, but from my training institution, I have done 2 projects.
Okay, yeah. I'm asking about a training institution only.
Yeah.
Which technology you have done?
28 nanometer, sir.
Sorry?
28 nanometer.
28 nanometers, okay.
Yes.
What is the difference between 28 nanometers and 48 nanometers? What is the difference? Like, what will
actually
change?
The difference in for the 28, the gate length actually. The main difference is gate. We have decided this nanometer on the gate.
Okay. Yeah. Can you please tell me about universal gates? What are universal gates?
NAND gate, NOR gate, AND gate. These are the universal gates.
NAND NOR, right?
Sir, NAND, NOR, OR, AND.
No, I'm asking about only universal gate, not all gates.
Okay. Sir, NAND, NOR.
Okay. Anything more?
JOR gate.
JOR means XOR?
Yes.
Yeah, okay. Do you know the NAND gate is more used than OR gate? NAND gate. Not
yes,
NAND, NOR than OR.
So for the clock gating purpose, we normally used NAND gate. Actually, we do prefer NAND gate than the OR gate.
Why? Tell me briefly.
Yeah. So if you see the truth table of the NAND gate, okay. And also see the truth table of the OR gate. So for the OR gate, if anyone switch is on, it is always on.
Okay.
So it helps to turn on all the switches in our design. So it causes the power dissipation, right? But if you observe this NAND gate also, if any switch is on and another input is off, one input is on and another input is off, it will show the off, right? So that's why we prefer a NAND gate than OR gate.
Is there any difference? Like, is there any another reason?
So as per my knowledge, I know that.
Actually, it's. Do you know that electron, the flow?
Okay. The flow of electron. Yes.
Actually, the flow of electron is more than this NOR gate. That's why we use NAND gate more. Okay. Yes. Can you please tell me about combinational circuits?
Combinational circuit for the combinational circuit, right?
Yes.
For the combinational circuit, its output depends only the present input, and circuit diagram is very easy, and power distribution, leakage power is also very less.
Okay.
Compared to sequential circuit, but in the sequential circuit, the output is depend on the present input and past inputs also.
Okay. Can you please tell me about? Tell me a few combinational circuits.
Combinational circuits, right?
Yes.
This mux.
Okay.
Then half adder. These are the combinational circuit.
Yeah. What about decoder?
Decoder. Yeah, decoder and encoder also combinational circuit.
Then what is the difference between encoder and this mux?
Sir, for mux there are multiple inputs and we have to select only one by the help of selectable, right?
Okay.
But actually, sir, I have to go through for the encoder. I just forget.
Yeah, actually, we can simply say the encoder with select lines is mux. And okay. Do we use clock signal for combination circuits?
Clock signal for combinational circuit. No, sir. As per my knowledge, we select the input for by the help of selectable liner there, right? S0, S1, S2.
Okay.
Yes.
Yeah. Okay. You're correct. And what about the difference between combinational circuit and sequential circuits?
First one is in combinational circuit, the output is depend on the present input only. But in sequential circuit, the output is depend on the present input, like past input also. And combinational circuit does not hold any data, but sequential circuit we use as a memory, store the data. And combinational circuit diagram is very easy. And then the sequential circuit and power distribution leakage power is very less for the combinational circuit than the sequential circuit.
Okay. Okay. We don't have a register, right, for combinational?
So register is a memory; it stores the data.
Sorry. Yeah. Tell me.
So
sorry. Does it register? Does it store the data in a combinational?
Sir, for store the data, we normally use flip-flops, right? So it is 1 bit of data. So if you collect all this flip-flop bits, work as a register, right?
Yeah. That's why I'm asking. Okay. Can you please tell me about latches? Yeah,
latches is a sequential circuit, and it stores the data. It's a simple circuit. If we connect two latches, it's combined. Actually, it's form a flip-flop, sir.
Okay.
And one thing, latches is S trigger. We don't use any clock for latches. We use another for this.
Okay. If you use a clock to latches, what happens?
Clock signal is used for flip-flop, but I did not use clock signal for latches, sir. Because I know, as per my knowledge, actually, we normally use enable, right? So that's why it is level trigger. And as we use clock for the flip-flop, so that's why it is S trigger.
Yeah, actually, if we give clock to latches, it will work as enable only. That's it.
Oh, okay.
Yeah, that's what I'm asking. What is the difference between both combination? Flip-flop and latches.
The difference between flip-flop is S trigger, and latch is level trigger. We don't use any clock signal for latches, and we have to use this clock signal for flip-flop. And the diagram of the flip-flop is more complexity are there than latches. And so, sir, this is the thing. Sir.
Okay. Do you know applications of flip-flops?
Sorry, sir.
Applications of flip-flops.
Sir, we store flip-flop in our design to store the data.
Okay, I'm asking like whether any counters like that. Let's okay. Tell me about synchronous and asynchronous counters.
Sir, I have to go through that part actually.
Yeah. Actually, we use in counters for flip-flop. Flip-flops will use in counters for storing the data.
Okay.
Yeah, and what about synchronous circuits and asynchronous circuits? Do you have any idea?
Yeah, for the synchronous circuit, we use for the synchronous we use the same clock, right?
Yes.
We use normally 1 o'clock. Suppose there are two flip-flops are there. So for both of the flip-flops, we normally use the 1 o'clock signal. 1 o'clock.
Okay.
For the asynchronous circuit, we have to use the different clock signal.
Okay.
Different clock actually.
Okay. What about that? Do you know that? What is the latches? Latch up.
Latch up issues. Okay. Yeah. Yes, I know that. Latch up issues. That is actually unwanted low impedance path is generated between the two VGTs. so that causes the latch up issues. And we to reduce the latch up issues, we use well tap cells actually.
Yeah. Yes. Okay. 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 What happens if I give clock to this AND gate or OR gate? What happens?
Clock to AND gate or
OR gate.
Sir, actually I did not get it. Please.
Yeah. I am asking what happens if I give clock to AND gate and OR gate. Is it possible?
No, sir. As per my knowledge, sir, I don't. Actually, I did not get that. So that's why I'm not sure whether it is possible or not.
Yeah, actually we don't apply anything, and I mean the interviewer will ask. What do you know in CMOS?
Complementary.
Yeah.
Sorry, sir?
Yeah. What is CMOS?
Complementary metal oxide semiconductor. It's a combination of NMOS and PMOS.
Okay. Why we use CMOS over BJT and all?
Sir, actually, for the CMOS, it have more temperature sustainability. It is its structure diagram is very easy. Then it has more noise sustainability more than the BJT and other FET. And temperature noise. And sir, I actually forget another point. So actually, these are the advantages for using CMOS.
Okay. Okay. Do you know that sizing of?
Yeah, sir. Upsizing, downsizing is.
Yes. What are the types, and please tell me about that sizing concept.
Sizing concept means actually if our cell is 2x or 4x, okay, our cell size is 4x. So if you want to upsize the cell like 4x to 6x or 8x, so that means you have to upsize. You are going to upsize the cell, downsize the cell from 4x to 2x.
Are you there?
Yeah, yes, sir. Hello.
Actually, yeah, you are not audible.
Yeah.
Maybe network issue.
Hello, sir.
Yeah, you are audible now.
Okay.
Yeah.
Okay. So actually, when we upsize the data, right? When we upsize the cell delays, actually cell delays become less. When we downsize the cell delays become high. And when we upsize the cell, actually it width from source and drain become increases. So as the width increases, so resistance become less there. So the flow of current will be high there, sir.
Okay. Do you know the difference between flip-flop, like D flip-flop and D latch?
D flip-flop and D latch.
Yeah, what is D flip-flop?
D flip-flop is nothing but opposite to SR flip-flop. Okay. D flip-flop, sir, it's a flip-flop, but it stores the data. It's okay, but in case of SR flip-flop, we have to give many values, right? Like for 0, 1, 1, 0, like that, right? So if we use D flip-flop, if we give 0, then clock will get one value and D will get one value. So for the simplicity purpose, we normally use the D flip-flop.
What about that output? How it comes? How it varies with input, with respect to input?
Sir, I have to go through the
actually, D flip-flop doesn't have change in output. It gives the input to output, that's it. But the only difference is it adds the delay.
Okay.
Yeah, for that purpose only we use. Okay. Okay. Latch up. Can you please tell me about your PD, properly like a PD course?
Sir, PD course means?
Like what you have learned,
Okay.
what you have done.
Sir, for the first project, clock synthesis or replacement of the standard cells and macros, these tasks has actually had assigned for me, and I had placed all these macros and standard cells to the help of data flow line and the fly line analysis properly, sir.
Okay, what is fly line?
Huh?
What is fly line?
Yeah, actually the virtual connection between macro to macro, macro to inputs.
Input or output?
Macros to macros and macros to inputs and outputs. IOCL actually.
Yeah, yes. Correct. Okay, can you please tell me about notches?
Sir, notch.
Yes.
Actually, it is the unwanted things. If notches is there, so in case of while we are doing the verification of DRC, when we will go to check for the design, then it will show the DRC violation, sir. If notches are there.
Okay. What is synthesis?
Synthesis is the process of transport the high-level abstraction like RTL code to the low-level abstraction like netlist. So.
Okay. Can you please tell me inputs?
Yeah. For synthesis, sir.
Yes. For
synthesis, the inputs are the technology files, RTL, and constants. These are the inputs for synthesis.
What about libraries?
Libraries. Yeah, logical libraries, physical libraries are there. We don't use that libraries for synthesis.
Yeah, but we load, right?
Sorry, sir?
We load, right? We load
yes. We have to import the design before floor plan, sir.
Yeah. Okay, can you please tell me about types of senses?
The type of senses.
Types of senses. Do you know two types? One will done. Yeah, one will done earlier stage, and another one is after floor plan. Like physical, logical. Physical aware senses, logical aware senses. Do you know that?
Sir, physical cells and logical cells.
No, in synthesis we have two types: physical aware senses and logical aware senses. Do you know?
Okay. Yeah, correct. Yes, sir.
Yeah. Can you please tell me about both?
Sir, actually, this sense I know senses for UNIT. You know, UNIT, positive UNIT and negative UNIT. We use as a senses. So actually, I did not work on that. You say now physical aware synthesis, and actually we do the placement aware clock aware placement. Another is design aware placement. We have done two things here. But synthesis, I did not work on that.
What is the difference both clock aware and design aware?
Design aware placement, right? And the clock. In clock aware placement, we have to give priority to the clock signals. And the design aware placements, we have to give priority to the standard cells, how we put the standard cells in the die area.
Okay, if you are saying if you are in design aware, if you are giving priority to stand cells, what happens to clock, like timing?
Sir, during placement, the clock is totally ideal because clock will be created in the CTS stage, right? So there all the actually in placement we have to give the how our standard cell will be there in the die area, how it collaborate with these macros and all. We have to give more priority there, sir.
Yeah, that's correct.
Yes.
Okay, can you please tell me about inputs of PD and tell me about those files also?
Oh, okay. Inputs of PD. Then the first one is lib file, technology file. Then HDC constants. Then UF file, unified power format. Then SPIC file, standard parasitic expression format. Then dev file, design extents format. So these are the input for the physical.
Design extent format. Do we have def file in input? I mean, importing design.
No, sorry. Design dev file will come after floor plan. After floor plan, floor plan dev. After placement, placement dev. After CTS dev, it will come.
I'm asking about floor plan, not floor plan. The PD inputs of PD.
Okay.
Yeah.
Okay, sir. Then constants, left file, left file. Then technology file. Then UPF file.
Okay.
What else?
You forgot the main file.
So netlist, sir.
Yes.
Netlist, yes.
What about TLUP?
Table lookup plus table lookup plus format, sir. Actually, it stores the RNC coefficient. Actually, if we change the width, if we change the temperature, and how it affects the RNC value of a metal layer, it just is stored. Metal layers means RNC value. If we increase the temperature, if we increase the width, how its effect on RNC value of a metal layer, it is stored in the table lookup plus table format.
Okay, do you have any other use of that file?
Sorry, sir. Can you repeat the question?
Like, is it only used for this one only, or do you have any another use? What about mapping between files? Do we have the details? Details of mapping between two files.
Sir, actually, I don't know, sir.
Okay, actually, if you have two files, but in the two files we gave capital end and small end, then it will, but both are same. This TLP will map between those. Okay, you're good. What about that UPF? Where we use UPF? Do we need UPF for design? Yes.
Actually, sorry, sir.
Yeah. I'm asking, do we use UPF for every design, or we need for particular only?
Sir, we use this UPF file for low power technology, sir.
Okay.
So in the UPF file, it contains actually in which particular power rails we have to route it, right?
Okay.
And we have to use this IO buffer, retention flow, then level shifter, then IO buffer, retention flow, level shifter, and always on buffer, sir.
Okay. Actually, where we use in every design, or do we have any specific reason for using of this? UPF. Yes.
So if our design is a low power design, so then we have to take help from the UPF file, sir. And in every design, maximum design actually include this UPF file, sir.
Okay, I will say design is only a normal design. Like we have only one voltage only, but I need UPF. Do you agree? But it is block level. In block level design, I need a UPF also. Do you agree?
Yes, sir. I will agree, sir.
Yeah, actually, in block level means we will have more than one blocks, right, in chip. So for that, we will have different voltage in neighboring blocks. Yes. For that, we need that UPF also. So actually, UPF will use only for multi-design like that, logo design.
Yes, sir. Yes.
Okay. Can you please tell me about keep out margin?
Keep out margin is the minimum area where it does not allow to insert the buffer and inverters.
Okay.
So this is the keep out margin, sir. It is used to also reduce this congestion. We use the keep out margin to reduce the congestion.
Okay. What is the main purpose? Okay. It is only on purpose. Only another one. What is the difference between
actually in the keep out margin area, it does not allow to insert any buffer or inverter, sir.
Okay. What is the difference between blockages and this keep out margin?
Sir, blockages means is permanently don't allow to input buffers, inverters, anything.
Okay.
But in case of keep out margin, if you want to add buffer or inverter, you can.
Okay.
And
Okay.
one thing is keep out margin have the attributes like macro,
Okay.
but the block is totally block, sir. Though there are different types of blockages are there.
Okay. I will. What are the types of blockages?
Hard blockage, soft blockage, sir, and another is the partial placement blockage.
Okay. Can you please tell me about those three?
Hard blockage means we can't actually we can't insert any buffer and anything we can insert in if we use the hard blockage. In soft
Okay.
blockage it will allow us to insert buffer and inverters. And partial
Okay.
placement blockage is given by us. How many percentage
Okay.
you want to give as a blockage? We
Okay.
do normally partial placement blockage between the two macros. If we want
Okay.
to add some buffers and inverters later in the next stage, so that's why
Okay.
we actually we give the partial placement blockage.
Okay. Actually, the main difference is placement blockages do not move, but this keyword margin will move with macros.
Okay,
That is the
okay,
reason. Yeah.
okay, sir.
Okay. Can you please tell me about bonds? What are the types of bonds and what is bond? Why we use?
Bonds is the collection of cells together is called bonds, sir. And it
Okay.
is hard bonds and soft bonds are there.
What about types? How many types are there? Only two?
Sir, as per my knowledge, I only two know, sir.
Okay. Exclusive bond. Do you know exclusive bond?
No, sir.
Yeah.
I know, sir. It is under magnet placement stage.
Okay.
Bonds, then magnet placement, relative placement, reference placements are there. So, sir,
Do you know why we use bonds?
bonds used to reduce the, sir, if we bonds means what? When this assemble of some standard cells.
Okay.
When standard cells comes together, so the length, actually the length between, interconnect length between two cells become less.
Okay.
Interconnect length means the metal layer, right? RNC value will be less. RNC value will be less means IR will be less. Voltage drop will be less. So these
Okay.
are the advantages, sir.
What about timing?
Timing also will be good, sir. Timing also will be good.
Yeah. Actually, it will be used for timing only. I mean, in timing improvement only for
Okay.
setup violation. Yeah.
Yeah, sir. If IR drop is less there, then obviously our cell will work fast, right? Timing will be fixed.
Yeah. Actually, it is. Yeah. Can you please tell me the timing violations?
Setup timing and the whole timing violations.
Yes.
For the setup timing, the minimum amount of time where the data should be stable before the clock activates. This is called setup timing, and hold timing means data should be stable after the clock activates. And the hold time violation is occurred when arrival time become less than your required time.
Okay.
That causes the hold timing violation. And setup timing violation occurred when your required time become less than the arrival time, RT minus AT. If the RT value become less, then setup violation will happen.
Okay. Can you please tell me about slack?
Slack means there are two types of slack: positive slack and the negative slack.
Yeah. Just tell me about slack only.
When the slack is nothing but, sir, for setup required time minus arrival time. This is for setup. For hold, it is opposite. Arrival time minus required time. And
Okay.
positive slack is when the capture clock comes late than the launch clock. That is called a positive slack. And negative slack is when the capture clock comes first than the launch clock. And it is called a negative slack.
Okay. Yeah, I'm sorry. Do you know skew? What is skew?
Skew is the time difference between arrival of a clock signal in one register in one clock domain or between domains.
Okay. What is the difference between clock uncertainty and skew?
Sir, uncertainty is the uncertainty. Sir, actually, I read a book. In uncertainty, skew is totally same. For the setup skew, jitter, margin, and uncertainty is there.
Okay.
For hold, uncertainty. For hold, jitter, not jitter, margin and uncertainty is there. For hold skew.
Okay.
And sir, uncertainty and skew is almost same, sir. Almost same.
But only one difference is there.
And we can say that skew means that is slew. I am talking about the slew. And it is skew. Sir, skew is, as per my knowledge, uncertainty and skew is same.
Actually,
so what is the difference actually?
Yeah, it is. Skew is across chip, like chip or block. That uncertainty is between the sequential elements.
Okay.
Yeah. Okay. What is the difference between latency and insertion delay?
Latency and insertion delay. Okay. Latency is virtual delay, sir, and insertion delay is the physical delay. Latency is given through the HDC cell. Okay, this is the virtual. The delay between this point to this point might be right there. And after clock synthesis, the value we got, that is called the insertion delay.
Yeah, actually after CTS. Okay. CTS. Can you please tell me about CTS? What is CTS?
Clock synthesis.
Yes.
Actually, it is a process of distributing the clock and balancing the load to all the sequential circuit. And in case of CTS, we use buffer and inverter. Actually, we insert the buffer and inverter to get the minimum skew and the minimum insertion delay. Okay.
What is HFNS?
High-fan-out net synthesis. It have a relax, rise and fall stem. And high-fan-out net synthesis is seen in selectable line enable. We use this high-fan-out net synthesis.
Okay. Then what is the difference between HFNS and CTS?
In clock synthesis, the clock have equal rise and fall time, but in high fan-out net synthesis, it have your relax, rise and fall time. Clock synthesis is give more priority to the switching. It is dynamic switching is there for the clock synthesis. But in case of high fan-out net synthesis, it is static, so it does not give more priority for the switching.
Okay. What about that? In which path both will work?
Sorry, sir.
Like which path? Like data path and clock path will be there, right? Yeah. Which path will use by clock? CTS. So it is. Yeah, that's what. Okay. What is the difference between this? What do we say? A little bit. Why high metal layers are used over low metal layers for power design only, for power distribution only?
Sir, can you repeat the question? Why?
Why high metals are used to power distribution over low metals?
Okay. See, for the high metal layers, resistance is very less.
Okay.
Resistance very less means your IR drop will be very less, current will flow properly, and the delay will be very less, and timing will be fixed. So that's why, sir, we use higher metal layer normally.
Why higher drop is less in higher metal layers?
Higher metal layer, sir, its resistance value is less than a lower metal layer.
Yeah, why?
Because its width is very high, a little bit high, sir.
Actually, the power is applied for higher metal layers, so higher power will be there. While it is coming to lower metals, the drop will be due to the resistance. Higher drop will be more.
Yes, sir. Yes.
Yeah. Okay. Can you please tell me about M1 layer? Why we use M1 layer? For what distribution we use M1 layer.
For the sir, to join the VDD connections, we use this metal ones.
Okay. Can you please tell me about site rows?
Site rows. Actually, the site rows is the row where we used to place all the standard cells are placed there,
Okay.
and we use the end cap cells at the end of the site row, sir.
Okay. Do you have any VDD and VSS for tab cells? Sorry, for site rows.
Yes, sir. Site row, sir.
Okay. Can you please tell me about rails?
Rails is actually rails rings. Actually, rails brings the your power connections from the source of the power to our design, sir.
Is it source or is it mesh?
So mesh structure is there, sir, from the mesh actually.
Okay. Can you please where it will lay on? In which metal layer this rails will lay on?
For metal layers, 5 we use rails.
No. Actually, we use it for the rails will lay on metal 1.
Okay.
Yeah, because it is the lowest metal and it is for stand cells.
Okay.
Okay. Okay. Can you please tell me about RC delay?
Sir, RNC delay.
Yes.
So resistance and capacitance delay.
Yes.
RC max
Actually,
delay, RC min delay, C max delay, C min delay.
I'm just asking RC delay. Why RNC gives the delay? But what combination like? Just tell me.
Because sir, C here represents the output load capacitance, sir.
Yes.
And R value is the internal cell delay. Actually, if you break the cell, there are resistance inside the cell, right? And
Yeah, if you want to share your screen and draw, you can do it.
Sir, actually, I never tried, so that's why I'm not sure how to draw. Sir.
Okay. Actually, I didn't join through laptop. That's why. Okay, no problem. Go ahead.
Okay. Sorry, sir. Actually, I don't know how to draw. This is the first time.
Yeah.
No, actually, you're asking like that, sir.
Yeah. Okay. Okay. Let it be. What is cell delay? On which constraints it will give the cell delay will depend.
Cell delay is it depends on two things: input transition and output load capacitance, sir.
Okay. What is input transition?
Input transition. Actually, we have to give the transition. That transition, actually, transition means to change the logic from logic 0 to 1 and 1 to 0. So you have to give the transition, how much transition is cell to takes turn on and off, sir.
Okay. Can we tell the time take? Voltage from 10 to 100. 90 and 90 to 100.
We can say that from 10 to 90 means that 80% we use voltage for starting our actually the make channels between source to drain. Just
Yes.
start to make channel, right? Between 80%. There is a relative point. When it reaches the relative point, then our transistor start working, sir.
Okay. What are the physical cells?
Physical cells are well tapped cells, end cap cells, spare cells.
Okay.
These are the decoupling capacitance cells. These are
You're
the
saying spray cells, right?
Sorry, sir.
Spray cells. Did you say spray cells?
Spare cells.
Yes.
Yes, sir. Yes.
Yeah. What is the use?
Actually, we use spare cell. We can use during placement, after placement, and before placement also. So it's depend on us. If we actually if you want to place the spare cells during placements, we have to take help from our tools, sir.
Okay. Yeah. Okay. Do you know align and align? The command align. Align and distribute.
Align and distribute. Okay.
What we use?
So it is familiar to me, but now I forget. Sir, please tell me. Actually, I forget this.
Well, you use it to place the cells.
Okay.
Macros.
Okay.
Yeah, LN is for only one macro and distribute is for a number of macros, like giving offset value or anything. Okay. Do you know the offset value?
Yeah, sir, I know the offset value. It is the distance, so the difference between the core area and the die area.
No, I'm asking offset value. No, I'm not asking about IO.
What is offset?
Yeah, what is offset value? Can you please tell me the formula?
Sir, I don't know the offset value formula, but I know the channel length formula, sir. Actually, the channel gap, 2 macros. What is the channel distance between 2 macros? I know that only. So
Can you please tell me that?
Sorry, sir?
Yeah, tell me that channel length formula.
Channel length formula is between 2 macros, right?
Yes.
So number of pitch.
Okay. Is it number or width of the metal? I mean pitch of the metal.
So number of pitch of the metal, sir.
No, actually not number. It is number of pins into pitch of the metal.
Correct. Then
that is a
horizontal and vertical layer by 2 divided by 2.
Actually, it is itself pitch. I mean offset.
Oh, okay.
Offset is the number of pins into width of the pitch of the metal by that number of
horizontal and
available metal layers available layers for routing into available routing layers by 2.
Yes, sir. Yes.
Actually, it is the minimum distance between macros.
2 macros. Yes.
Yeah, we have the if we do not give offset value between macros, what we call? We have 2 types of placing macros. Can you please tell me?
It is called, sir, if there are no gaps between non-abundant placement macros. Non-abundant.
No, actually it is abundant and channel macro.
Okay. Sorry, sir.
Yeah, okay, no problem. Can you please tell me the outputs of that placement? Output reports or output sanity?
For the placement, first one is my standard cells are placed properly, that reports. Then timing reports and placement depth and log files.
Okay. What about utilization report, power report, timing report?
Sir, I mentioned timing report, but I didn't mention utilization report and the power report. Sorry.
Yeah. What about TCL? DEF.
DEF file.
Yeah. One question. Did you work in automation or manual?
Sir, first I put these macros manually. I did, but then it was 1450 macros in my design, so it is very tough to do manually. It actually time consuming. So that's why I took. Sir.
What is the difference between manual placing and automation? Automate.
Sir, manual placement is you have to place the macros by the help of data flow lines and the fly line analysis. You have to take the macros and you have to put in this die area. But in manually the tool will do it. Actually, which are written in the tickle script now. So just you have to run this tickle script.
Okay. What is the most useful method? Is it automation or manual?
Sir, if time is not matter, then manually we can do. But automation is good, sir, because it's not time consuming.
Actually, I will say it's manual.
Okay.
Actually, the placement and everything will be calculation. We have to do calculation for placing macros. So for that, we have to check pitch value, channel value, and everything. Not pitch value, offset value. So for that, we should place manually most of the times.
Okay.
If you don't have time, then we, as you have said, we have.
Okay.
Can you please tell me the main concerns for in CTS?
Main concern for CTS is DRC, sorry, design rule check, sir.
No, I'm asking what we have to take care.
Sir, we have to take care minimum is to minimum insertion delay.
Okay.
And the NDR values is there, non-default routing.
Okay. You are saying NDR, right?
Yes.
Can you please tell me about NDR?
So NDR is nothing but double spacing and the shielding. We use this NDR rules in our actually we define the NDR rules in our cts.tcl file to reduce this crosstalk issue and the electromigration issues.
Okay. And is there anything else?
Means we can reduce this means false with violation.
Okay. Is there anything else? Okay. So it's good, but we have another one also. Hardening the clock signals. Did you hear about this?
Sir, what, sir? Which one?
Hardening the clock signals.
No, sir.
Yeah, actually, it will harden the means it will make it will give good strength to the clock signals also. Actually, it is defined by user only. User defined rules.
So
Okay.
just, I have to keep notes, sir. Please tell me the name. This is new one, so that's it.
Yeah, actually, you can go through VLSI Backend Adventure. Okay.
Okay.
Yeah. Okay, good. Can you please tell me about routing concepts?
Routing is nothing but actually it's making physical connections between this input one cell input pin from another cell. Actually, it's making physical connections.
Okay. We have three types of three things in routing. Can you please tell me? How do you, depending upon that one?
Detailed routing, then source and repair, and another is global routing.
You said second one, it's not clear. Can you please tell me again?
Detailed routing.
Okay.
Global routing and source and repair.
Okay. What about the placement?
Placement is detailed placement and local placement and the global placement. Sir.
Can you please type properly, like from number 1, number 2, number 3, in order? Does it take time or can I tell?
Yes, sir, you can tell. Actually, it will be good for me also.
Yeah, actually it is course placement, legalized placement, and detailed placement.
Okay.
Yeah. Okay. What violation? What you will do in routing? What you have done in routing? Can you please tell me?
Sir, routing, we have to route the clock signal in routing to make a physical connections between the signals.
Yeah. Hello?
Yes, sir. You're audible, sir.
Yeah, what will you do? Like, what violations you will check, and I'm asking about that. What you have done in your project?
Okay, sir. Actually, in crosstalk violations is done in during actually, sir.
Okay.
Routing, sir.
Okay. Can you please tell me about steps from in routing from starting to ending?
Okay, sir. We have to take the inputs for routing. Actually, the outputs of the clock synthesis. For the inputs, we have to take a CTS zip file, all the timing reports and the insertion delay reports. All the reports we have to take as inputs for the routing and NDR value. We have to add the NDR values in case of routing. So then we have to mention the NDR value. So which metal we have to use for the routing layers, routing the signals, and we have to make sure that we don't route the clock pin, because clock pin is used lower metal layer, and as we use the higher metal layer in case of NDR value, so there will be condition might be there. So and we have to take this detailed routing, this search and repair and the global routing, and these other things, and routing optimization we have to do.
Okay. Do you know self splitting?
Self getting.
Splitting.
Cell splitting.
Yeah.
Yes, sir. I know, sir. Actually, that means we have to split the cell, sir.
Why do we split the cell?
Actually, see, we split the cells, sir, to reduce the condition, sir.
Okay.
Then, and if we split the cells, actually, that will help us to remove the CRPR issues, because if we combine.
Okay. Does it reduce the what is that output capacitance? I mean output load.
If we split the cells, right?
Yeah.
Yes, sir. It will affect the output load capacitance.
Yeah. How does?
Sir, I have to go through on this, sir.
Okay, actually, self-splitting, it will reduce. I mean, not self-splitting. It will reduce that output by splitting that to number of outputs. So the gate will add to. I mean, not gate, buffer will add to the remaining one. So while setting, I mean, actually the main process is we have to give the minimum output load. I mean, output nets. Then other than that, I mean, it will allow to those outputs only. Other than that, if we have any outputs, then it will add buffer, and from through that buffer only, it will the remaining nets will connect.
Okay, sir.
Did you got it?
Yes, sir. Yes.
Okay. 1 minute.
Yes, sir.
Okay. Can you please tell me about your project briefly?
Sir, my project was ARM Cortex semi unit. So as I told you before that placement of the placement of the standard cells and macros was assigned for me, and I have done this timing analysis also, and some conditions are there, so I had to fix all these condition issues also.
Okay. Can you please tell me about your frequency?
Sir, 448 hertz it was frequency.
Okay. Can you please convert into nanoseconds?
Sir, sorry, sir.
Can you please convert the 448 megahertz into nanoseconds? You can use a calculator for saving time.
Okay, sir.
How do you check? Just give me the formula.
Sir, we have to divide. We have to multiply this 1000. So with that, sir, to convert.
Yeah, I'm asking formula. We have formula for that one. Simple formula you might know, but you forgot.
Sir, please help me. I think I might have forgot, sir.
Yeah, time to frequency conversion. Do you have any idea?
Okay. T is equal to 1 by f, sir. This one.
Yeah, that's what we have to just do that only.
Yeah.
In numerator, we have to give that nanosecond. I mean nanosecond in the sense 10 to the power 9, and in denominator you have to give that 448 into 10 to the power 6.
Yes.
Okay.
Yes. Sir,
Yeah, I am asking something, I forgot it. Okay, let it be. Yeah, how many pins you have used for, how many pins you have used for your design?
how many input pin?
Yeah, you used for your design.
Sir, I did not count, sir, actually. So input pin. Sir, I got a block and it is come from my top level person, right? So
Okay. Okay, let it be. Offset value you have given, right? Offset value. Yeah, what is that offset value of your design?
Sir, 0.02, sir.
0.02. Actually, it is very close. Routing doesn't happen. I mean, doesn't happen in the sense routingization will happen.
So actually, I forget. I think it was 0.
Is it 1.16 or anything?
No, sir. Actually.
Okay, let it be. Just take care of all these things which I have given. I mean, asked you.
Yes, sir.
Yeah, actually you are good, but that's why I'm asking this much.
Thank you, sir.
Yeah, another one is okay. Do you know that pitch of your layers for top layers?
Sir, can you repeat the question again, sir?
Like for design your block, you will have done your not macro, the ring power plant, right?
Correct.
Yeah, what is the pitch of the metal and what
Sir,
metals you have used?
Okay. Metal. Pitch of the
Yeah.
metal, sir.
Yes, pitch.
Sir, I'm just giving the process how to just find out the pitch of the metals. Sir, though
Okay.
actually I don't have forget. Actually, I forget this value. To identify the pitch of the metal, then you have to take the metal.
Okay.
Then you have to go to the technology file, and
Okay.
you have to write the slash this met. Actually, you have to write the slash this metal layer. Actually, which metal layer you have selected. Then it will
Okay.
show what is the pitch of the metal, sir, and how can you what is the pitch of the metal, width of the metal, all these features of this metal layer you will get, sir, in the technology file, sir.
Okay. Okay. Let's go for practical. What is a HDC file?
Synopsis design constant, sir.
Okay, I'm asking like
What it constant?
yes.
Okay.
What it will contain?
All this HDC file contains your units of capacitance, time.
Okay.
That's it. Then uncertainty value for setup, uncertainty value for hold. Then multi-cycle path, half-cycle path, virtual clock, non-virtual clock, normal virtual clock. This normal clock. All our definitions are there actually. All the things are written there. Then your if there are any false path, you have to mention in HDC files also. Latency value will be there. These are the things are in HDC files.
Okay. Okay. How do you define clock in HDC file?
Actually, for the normal clock, actually real clock, I have to create clock, then a clock in, then I have to give the clock source point, then I have to give the how many percentage of the duty cycle set and wave also.
I'm asking how do you define? We have to define these all in HDC, right?
Yes.
Yeah. How do you define that one? At what command?
So create a clock.
Yes. Okay. What is clock group? I mean path grouping. Did you use it in your project?
Sir, I have uses path groups. There are many path groups like input to register, register to register, register to output, and input to output, sir.
Okay. What is the use of path grouping? In which, what is the use and where we will use? And in which stage?
Sir, actually, path groups, yes. Sorry, I have used path groups in placement stage, sir.
Okay. What is the use?
Sir, the path groups we mentioned because the data should be like that: register to register, register to output. Data will go from input to register, register to register, register to output. So that's it.
Okay. Yeah, actually it is used in timing violation to say for setup time violation.
Okay.
Yeah, setup time will be done in placement stage, right?
Correct.
In that stage it will in for that one it is will use. Okay. What about cloning?
Cloning and buffering. Actually, cloning means one kind of split.
Okay.
As from one cell to two cell, from two cell to four cell, like that. So it is called cloning. Sir, the cloning, the advantage of cloning.
Hello? Hello, am I audible? Hello? Am I audible? Yeah, am I okay? I think you got power loss.
My current on, sir.
Yeah, it's
connecting with phone, sir. Sorry, sir.
Okay, we are almost done. Not almost, we are done. Okay.
Sir, if you have question, you can ask me, sir. No issue, sir. May I call you, sir, by phone number?
Yeah, okay, we are good. Actually, I will call you after this one.
Okay, sir.
Yes. Thank you.
Yeah, thank you, sir. Thank you so much.
Yeah, just
how was my interview, sir? Please give me feedback, actually.
Sorry?
So give me feedback, sir. Actually, I want to, sir, brush up myself.
Do you have an interview? You are saying something?
Sir?
You are saying you have interview?
No, actually, give me feedback, sir. Actually, in which portion I have to brush up myself.
Yeah, okay. That's what I thought you were saying. You have interview. Okay. You are good, but you are good, but you have to check that digital electronics somewhat. That's it.
Yes, sir.
And in digital electronics, you are confusing somewhere. But
yes, sir, actually, I did not get more time, sir. Actually, I know all the things, but so due to less of time, sir.
Yeah, actually, I am also student in this VLSI VLSI for all.
Okay.
Yeah, actually, in my interviews, I have they mostly concentrated on this one only, this digital electronics.
Okay, so which company you are in now?
No, I'm actually I have give interview for one company, but I'm not going to there because I'm not interested in that company.
Okay.
Yeah, actually I have worked in Capgemini for this one analyst role, but I just wanted to come to this PD. That's why I'm searching for that. Okay, we'll talk after this one.
Yeah, sure.
Yeah, bye.
Bye.
Yeah. So you can drop the. You can stop the recording and.
Okay. Sure.
No, I'm asking Rajat sir. Hello. Okay, we will end the session. I will call him personally.
Okay.
Yeah.
Thank you.
Thank you.